So it's been a long time since I released an entirely new board, and today I'm going to be releasing a new one that I think is going to push the limits of what is possible with hand wiring. So instead of talking about it, let's just jump in and we'll take a look. This here is the ScottoWing. It is an ergonomic Choc keyboard, and you can see that we have this dual color thing, and then on the back I have like my logo going on there, which is pretty nice. But it is a sandwich mount design, so we have a middle layer at bottom and then a top. And the big thing you're probably noticing right now with this is all these screw holes on the edges here. Those are both a stylistic and a functionality choice, because first off, I think it's going to look pretty cool with all the screws there, and it's kind of cool to have a bunch of screws on your board. But also, this board is so thin, you can see that these are only 1.2 millimeters thick. That's very flexible. So if I was to just mount this with just a few screws, this would be flexing all over when I go to type on it. So by putting all those standoffs there, it's going to give it a lot of strength because it's mounted on metal instead of just this plastic suspended in the middle. Now, the first thing I have to do with this is I have to actually just attach this top plate to the middle layer. And you'll see that's what's really cool with this is that once these are attached, everything wires up on the plate here, and then we just kind of put the back plate on. But that means I'll be able to get everything wired really cleanly, which is going to be absolutely crucial for this because there's only 6 millimeters there to work with. So everything needs to be wired up really, really cleanly in order for the back plate to close on, because this back plate is really not even a back plate. It's kind of like a 3-layer thick print. So it's really thin. I mean, you can almost see through it. So it's super thin. So that needs to be able to go completely flush on this to fit right. So I'm going to go ahead and screw those on right now, and I'll be back in just a few moments. Now I have all the screws and the standoffs on the top plate here. There's about 150 components in total for this build, so about 50 standoffs, then 50 screws per side. But what I can do at this point is just take this and put it down and then grab this middle layer, and this middle layer has a section here for the controller. You can see that there's a thinner part and a taller part. That thinner part should align with the plate, and you'll see that this will make it very easy to wire everything up. So the controller will sit in the middle there, and then I can wire all my stuff directly to it, which is absolutely essential for this build because of how little clearance I had there. I mean, we're talking 6 millimeters. So what I'm gonna do now is I'm gonna grab the switches, which these are just Choc silvers, and they're using a clear housing. I was originally gonna use Choc reds, but they had a black housing. And this will become more relevant later when I talk about the keycaps, because that clear housing is pretty much essential for this build. But I'm gonna pop these in really quick, and I'll be back after that. Now you can see that all the switches are mounted into the plate here, and what I'm going to start with here on this board, opposed to how I normally do boards, is I'm going to do the rows first instead of the columns, because the rows are the ones with diodes. And if we look at the wire for the row here, you can see it's bent because it's a column staggered board. It'd be very hard to get the intersection heat shrink on there to insulate the columns from the rows. So by starting with the rows first and doing the diodes first, it will make it really easy to do the columns later because they're just vertical. So I'm going to go through and do that now, and I'll be back in a few. There are the rows all wired up. As you can see, the diodes are running nice and neat to them. And at this point, all that's left for the matrix is to do the columns with the insulation. I'm just going to be using these heat shrink tubings that I pre-cut with the hot glue in them. So I'm going to go through and do those, and I'll be back in a moment to talk about the controller, because that's kind of when this build starts to differ from everything else I've done, because the controller is going to be mounted on this middle plate here, right in the middle, and then we'll be able to wire it up really neatly. So I'll be back in a few. Most of the matrix is wired up at this point, but what I'm running into right now is that this column needs to connect to the thumb cluster. So there's this one, and this one. They all need to connect to the thumb cluster. But if I run a copper wire down like that, it doesn't really connect the best, and there's a bunch of stuff in the way, and I'll have to insulate in a bunch of areas. So what I'm going to do instead is just take a copper wire and connect here. Then I'm going to take flexible wire to connect this to the bottom. So there's the entire matrix wired up. You can see we have the main section connected to the thumb cluster with these wires on both halves. And up until this point, this build hasn't really been special at all. It's just been a matrix with diodes, so a pretty standard hand-wired build. But what I want to talk about now is the controller. So if we put this down here and I just grab an Arduino Pro Micro, you can see that we can take this, slot it in there, and that pretty much fits just as you'd expect. But I'm trying to move away from Arduino Pro Micros because they're not really the best controller anymore, because they really have low memory and they're pretty expensive relatively to other controllers. So what I'm going to do with this, I'm actually going to take this out. I'm going to grab this new controller here, which is an RP2040 Zero. So you can see RP2040 Zero, has an RP2040 chip on the back there. It has like 2 megabytes of flash, and it's super small. I mean, compared to the Pro Micro, it's tiny. But the issue with this board is if we take it here and put it in here, you can see that it kind of wobbles around. It doesn't sit flush. So the way we're going to solve that is by using pin socket headers. Now these here are the pin socket headers we're going to be using. You can see there's just a male and a female half. And the half we're going to be using is just this female one. We're basically going to be reverse mounting it. So we're going to mount the controller here. So if I grab this, put it through here, you can see we're going to kind of make an assembly like that, so that what we can do is mount the controller flat on there with hot glue, just as we normally do with a Pro Micro, except this way it will have it aligned perfectly. And this does have an LED on it, which will be kind of cool, because if we look, you see there's an LED right there, an RGB LED, which should illuminate this section. So I'm just gonna solder those up really quick, and I'll be back after that's done. So you can see I just used a breadboard to hold this in place, which is a tip I have, is use a breadboard when doing sockets now. It makes it really easy to get them exactly flush like that, so perfect 90-degree angle. If I grab this and pop it off, you can see I can remove these off the bottom, and then what we're left with is a perfectly flush controller there that if we grab our board, we can just pop it in, and you'll see it aligns with a USB port, and everything's good there. What I have to do at this point is just hot glue this in place. I have to do that off camera. It's like across the room. So I'm gonna go do that, and then we'll talk about wiring it. The controller is hot glued in place there, and the one thing with this that's gonna be annoying, at least for now until the firmware's on it, is that when I go to reset this, you can see the buttons are on the other side of this. I'm gonna have to use a tweezer to kind of get in there to press the button, which shouldn't be that bad to do, but it's just a pain for right now. So what I'm going to do now is just wire everything to it, and this is going to be really clean to do because it's just in the middle, so I can route everything really neatly and cut it to length to perfectly match to where this controller is. I'm going to go through and do that and be back in a few. So there's the entire board all wired up, and I didn't record that part because I was running out of storage on my main recorder here, and then I remembered that I actually have SD cards in my camera, and I could have recorded that, so I didn't record the wiring. But it was a massive pain because what ended up happening is that for the first time ever, I got a dead on arrival controller. So I had to basically disconnect this completely and then resolder a new one on, and it was a massive pain because I had to basically cut all this wire off. I had to deal with the glue and stuff. But this is working now. I already tested it. It works. At this point, what I want to do is put the back cover on, and then we'll put the keycaps on, and then we have a finished board. We can do a typing test, and that's the build. There's the board all completed on the back. It's fully assembled. We have a nice textured bottom here, Scotto Keeps logo and some rubber feet. And I did want to quickly mention this thing here, which is an electric screwdriver. Now, this isn't sponsored or anything, but I will have an affiliate link in the description if you want to get one. This is something I've been recommending for a while, but they're normally not as useful for like a normal build where you only have a couple screws. When I build like this saved my life because it's like 100 different screws I have to screw in, and if I had to do those all manually, I'd be in massive pain right now, but this made it really easy to do. Other than that, what we have to do at this point is connect the keycaps, and these are what we're gonna be using. They're just some resin printed keycaps I printed on my resin printer in Siraya Tech Blu, so they're kind of this transparent. And the reason I use Siraya Tech Blu is that anytime you're using like keycaps that are printed out of resin, you wanna make sure it's a biocompatible resin. I'll link a video I did talking about that in the top right. But we're just gonna put these on the board. I'll be back in a second. So here is the fully completed board with the glass keycaps. I think it looks really good, especially that side profile with the blue there. And then we have the back on it. But you might have noticed while I was putting the keycaps on, I kept flipping it upside down and like tapping the back, trying to get the keycaps to fall out. That's because resin keycaps, especially for chalk, are often really hard to get the tolerances right. So some of them are really loose, some of them are really tight. That's why I printed a bunch of extra here. These are pretty much all loose ones, but yeah, this is pretty much done at this point. And now all that's left to do is do a typing test. We'll talk a little bit more about it, and that's pretty much it. So yeah, that's the entire build of the ScottoWing, and I think it looks really nice. I think these transparent housing switches look really nice with the transparent keycaps. The purple side looks really nice with the iridescent, like kind of different color based on how you look at it. I was going to originally do that black, but I think the purple looks way better. And then of course the back with the Scotto Keeps logo, and then the textured bottom, it just looks like a really nice board. I think it's one of my better looking boards that I've designed. The original design of this center was this circle, which is on the repo, but I didn't like the blank space on it, so that's why I didn't go with it. There is also this one too, which is a hypnotic one. This one hurts my eyes, that's why I didn't go with this one, but that's on there too. And also, this is my first board that features a 6-column variant too. So if you want to build it with a 6-column, so you have like actual enter, shift, tab keys, stuff like that, you can do that. That's on the repo as well. But I did want to mention that I do have a Patreon now. If you want to support me through there, I'll link that down below. And yeah, comment, rate, subscribe, and I'll see you next time.